Number 11. Okay, this looks like a fun one. We've got 6 different angles going around a full circle or 360 degrees. In the figure above, lines K, L, and M intersect at a point. If x plus y equals u plus w, which of the following must be true? So we've got one equation, which is sum of two angles equaling another sum. We should also know offhand that opposing vertical angles are congruent. So y there must equal u, for example. Likewise, z must equal w. Those are opposing verticals. And x must equal t. Those are opposing verticals. So I've got 4 equations. I can hopefully, substitute and check these equations to see which of my Roman numerals is correct or incorrect. So to find the ones that are correct probably takes a limited amount of time for substituting and figuring it out. But what about a wrong answer? This problem could be a real time drain potential. You could be plugging in all day long and never getting it to be true. And eventually you'll probably figure out, well, I'm just going to assume it's not correct. I think there's one thing we can do to sort of help save that time approach. So let's take note of that. And that's this equation here. X plus y, which is that double angle equation, equals u plus w, which is that double angle equation. Let's think about this conceptually for a second. That means the sum of two angles equals the sum of the other. That never means you can solve for any of the individual parts. So y equals u, because those are verticals. But how about x and u? I don't know the relationship of x to u. I don't know the relationship of y to w. They're not vertical angles, and they're part of the sum. So I can say right away, x equals u, we just don't know. Y equals w, we don't know. Keep that in mind because that might help us. Also, if these double angles are congruent, I know the opposite angles, z and t, must also be congruent. So it must be true that z equals t. So looking at this conceptually, I'm able to conclude a couple things that I think will be very important for solving this problem without wasting time. So with that, let's begin to sort of substitute and plug away and see which ones are true. Number 1, x equals z. So I have x plus y equals u plus w. Well, I can substitute y equals u in here. So x plus, instead of y, I'll write it as u, equals u plus w. Okay? Well, instead of w, since I need to find a z here, instead of w, I'll plug in z. And I can do that with my second vertical angle equation. X plus u equals u plus z, substituting that for w. My u's cancel each side. X equals z. So Roman numeral number 1 is true, right? I solved that by using substitution among my different equations. Number 2, y equals w. Well, again, here I could have spun my wheels for minutes and minutes trying to substitute and finding it doesn't substitute if I didn't conceptually realize above that the relationship between x and u and y and w are not clear. They don't necessarily have to be the same. So I'm pretty sure we're going to say number 2, Roman numeral number 2, y equals w, will not necessarily be true. Remember, our condition is must be true. Okay? Last but not least, 3. Roman numeral 3, z equals t. Well, conceptually, we realize z probably has to equal t here as well. If the double angles opposite are the same, those two remaining angles, because each creates 180 degrees on either side, top and bottom, they must be equal. We can confirm the algebra on that by going through that situation again with that x plus y equals u plus w equation. Let's try and substitute and find z equals t. So right now I don't have z or t in that equation. I'm going to substitute in t for x. So x becomes t plus y equals u plus w becomes z. Now I have my z's and my t's in there, which is what I'm ultimately trying to set equal. We know from, again, that first equation of opposing vertical angles, y equals u. So I'll cross out the u, cross out the y, substitute u. I could do either way. We'll find the u's are the same. Therefore, they cancel on both sides. T does equal z. So algebraically, we've shown number 3, Roman numeral number 3, is also correct. Something we conceptually kind of knew above, but now we've actually shown that and have more confidence that it's true. So that means the correct answer for number 11 is 1 and 3 only. Be careful. If you spent all day trying to substitute and prove y equals w, you could waste a lot of time on this problem. So think about it conceptually as well.